Hey Bengals, this is Mrs. Hydrick, and I'm here with your density video. Looking at your density matrix, your essential questions for this video will be: how do you calculate density? Is density a physical or chemical property? And how can density be used to identify an unknown substance? So here we go. First of all, the definition of density, which, by the way, density is a physical property of an object, which describes the relationship between the object's mass and its volume. So how much matter it has and how much space it takes up. You can also sort of say basically how tightly packed the molecules are within a space. So how much matter is packed into a space describes an object's density. And all substances have a unique density, and you can use an object's density to identify what it is. And we'll be doing that in just a second. But here's a question for you first. Which box has a higher density? Man, I hope you said the box on the left, because there are more molecules packed within that space than the box on the right. Both boxes occupy the same amount of volume, but with more mass within that volume of space. The box on the left, this one here, has a higher density than this box over here. Same amount of volume, but a lot fewer molecules packed within that space, so a lower density. This is the formula for calculating density. Whoosh, whop, bam, zam, boom, pow. How'd I do that? Well, I just had the animations already there. Anyway, here's the formula for density. D equals M over V, or density equals mass divided by volume. And in case you have forgotten, grams is the unit that we use to measure an object's mass. And there are two different units we can use to measure an object's volume. We can use centimeters cubed, which is the unit that we use when we're measuring the volume of a solid object, or milliliters, which is the unit that we use when we are measuring the volume of a liquid. Since there's two units for volume, there are also two different units you might see for density. You might see density described as gram per centimeter cubed if you're describing the density of a solid object, or grams per milliliter if you are measuring the density of a liquid substance. It doesn't really matter though, because 1 centimeter cubed is equivalent to 1 milliliter, so those two units really are interchangeable. Now, when you find volume, there are three different methods that you're going to be using to find volume, and you're going to choose the method based on the object that you are measuring. If you are measuring a solid object, a regularly shaped solid object with straight edges and a very defined length, width, and height, then you are going to use this formula here. Length times width times height. So you're going to use this formula to find the volume, which you then plug into the density formula to calculate the density. And so when you are using this length times width times height volume, formula, the unit will be measured in centimeters cubed if the length, width, and height are measured in centimeters cubed. Now, if the length, width, and height are measured in meters, then your unit might be meters cubed. Or if it's measured in inches, it might be inches cubed. So whatever the measurement is for your length, width, and height, that will be your unit. And just make sure you cube it because you're multiplying it 3 different times. Now, if you are finding the volume of a liquid, it's pretty simple. You just put that liquid into a graduated cylinder and it will tell you what the volume is. And a graduated cylinder is going to be measuring your volume in milliliters. Go get him, Jake. So milliliters will be your unit for liquid volume. Hey, hush. I'm making a video here. Sorry, guys. And then there's one more way you might find volume, and that's when you're looking for the volume of an irregularly shaped solid. That would be a solid like this marble. This marble does not have a very defined length, width, and height. So I cannot use this method, but I can use a method called displacement. And for the displacement method, you take the final water level, because you're going to be using a graduated cylinder, and you subtract the original water level. For example, let's take a look down here. Down here, I have a graduated cylinder with water in it, and the volume of water before I put the object in it is 200 milliliters. Then I put the object in it. This object happens to be a rock, or it could be a marble, or whatever irregularly shaped object you have. And you put that solid object into the water. What's going to happen to the level of the water? Well, if you've ever gotten into a bathtub, you know that the water level will go up. It rises whenever you get into the tub. And the same thing happens within the graduated cylinder. The solid object will cause the water level to rise. In this case, it rises to 260 milliliters right there. And so the volume afterward is 260. So I take 260, I subtract 200, and I'm left with 60 milliliters as my volume of this rock down here. And that's the displacement method. Let's take a look at this density stack, because a density stack can really be useful for identifying the density of an object. For example, which liquid is most dense? Let's answer this question. Which liquid is most dense? Well, you look at your density stack and you see this light corn syrup down here is at the very bottom of the stack. So it is the most dense with a density of 1.3 grams per milliliter. Question 2, which liquid is least dense? Well, the least dense liquid is going to be the one on the top, the one that's floating above all others, and that's the isopropyl alcohol with a density of 0.85 grams per milliliter. What is the density of water? Don't remember? Well, let's take a look at our density stack. Here's water right here. It's been dyed a red kind of pink color. And you can see that the density of water is 1.0 gram per milliliter. Now, this is an important density for you guys to know. It's something that you really just need to kind of lock into your file cabinet up here because you will be answering a lot of questions that just have to do with the density of water. So you need to know that the density of water is 1. Now, if I place a marble into this density stack, and if the marble had a density of 2 grams per milliliter, where would that marble end up within my stack? You think you know? If you said the bottom, you're right, because 2 grams per milliliter is more dense than even the light corn syrup, so that marble would roll all the way through the isopropyl alcohol, all the way through the vegetable oil, all the way through the water, all the way through the dish Dawn soap, all the way through the light corn syrup, and end up right here on the bottom. That would be where my marble is. If a rubber band was placed into the density stack with the density of 0.89 grams per milliliter, where would it end up? Yep, right here between the isopropyl alcohol and the vegetable oil, because it's less dense than the vegetable oil, so it's going to float on top of that layer, but it's more dense than the isopropyl alcohol, so it's going to sink through the alcohol, but then stop and float on the vegetable oil layer. Sorry, bud. So here's some practice problems that I want you to work out on your Wix. I want you to write the question, and I want you to write out the 4 steps. Please make sure you show all 4 steps for all 3 practice problems. So the first problem, what is the density of a liquid with a mass of 55 grams and a volume of 55 milliliters? Well, we list the variables first. So first, we're looking for the density, so I don't know what it is. The mass is 55 grams. The volume is 55 milliliters. I write down my formula, density equals mass divided by volume. I plug everything in. Density then equals 55 divided by 55. And the answer is, worked it out real fast. Yeah, that one was easy. 1. Oh, mistake. That should be gram per milliliter. Gram per milliliter, guys. I'm sorry, I just caught that. So right here, please make sure you write the correct unit down for your answer. And that's gram per milliliter, not meter per milliliter. I'm sorry about that. You might see that again because I cut and pasted. Apologize, that was my bad. Number 2. A sample of a substance has a volume of 12.5 milliliters and a mass of 3 grams. What is its density? Well, let's write down the variables. Density equals, I don't know, that's what we're figuring out. The mass equals 3 grams, and the volume is 12.5 milliliters. Same formula, D equals M over V. Plug it in, and I get 3 divided by 12.5. And yes, I can have a bigger number down below the line. But remember, top dog goes in the house, and so we get 3 divided by 12.5, and your answer will be a decimal. It's 0.24 grams per milliliter. For our third practice problem, calculate the density of a 60-gram substance that has a volume of 5.7 milliliters. Well, here are my variables. My mass is 60 grams. My volume is 5.7 milliliters. My formula is density equals mass divided by volume. My density is equals 60 divided by 5.7. And here my answer is 10.5, and I'm sorry again, there's a unit mistake. That should be grams per milliliter right here, not meters per milliliter. Fixed it for this one, forgot for this one, guys. I'm sorry, I overlooked that, so please forgive me for this mistake. But this should be 10.5 grams per milliliter. Now that we've done these 3 sample problems, let's take this information and apply it to a density table. So we're going to use this density table to identify those 3 substances. We don't know what they are, but we did calculate their density. Number 1 had a density of 1 gram per milliliter. So using my density table over here, I look for 1 gram per milliliter, but it says centimeters cubed up here. Remember, it doesn't matter because a milliliter is the same thing as a centimeter cubed. And so the substance for question number 1 for our practice problems was water. Question number 2, we calculated the density at 0.24 grams per milliliter. So we use my chart, 0.24 grams per milliliter. Well, that's cork. So that substance that we calculated the density for in question number 2 was cork. Number 3, we calculated a density of 10.5 grams per milliliter. So we look at my chart. Here's 10.5 grams per milliliter or centimeters cubed, it doesn't matter. And it is silver. So we just used the density to identify those substances. We didn't know what the substances were, but once we found their density and we compared it to our density table, we could identify them. Which of these substances, 1, 2, or 3, will sink in water? Well, if water has a density of 1 gram per milliliter, any object with a density greater than 1 will sink. So I hope you said silver. Silver, 10.5 grams per milliliter, is more dense than water, so it would sink if placed in water. And cork, with a density less than 1 gram per milliliter, at 0.24 grams per milliliter, cork would float in water. So you can determine if something will float or sink based on its density when you compare it to the density of water, which again is 1 gram per milliliter. All right, guys, so that's your density notes. You are now going to be working some density practice problems, so I'm out.